While people are still settling in and grabbing some pizza, I have the great pleasure of introducing our speaker today, Aaron White. Aaron received his PhD from the University of Maryland in 2015, subsequently worked as a postdoc at Johns Hopkins, and then moved on to the University of Rochester, where he's now an associate professor. He has, and also the director of the Center for Language Sciences and the Formal and Computational Semantics Lab. He has especially, given his career stage, an impressive array of NSF grant awards, including an ongoing career award on logical form induction. Aaron is really unique in the combination of formal and computational work, as well as psycholinguistic perspectives, at just an incredibly high level of sophistication, which I think you'll see here today. Early on in his career, Aaron developed a mega attitude project on how the humans draw complex inferences from the thousands of English predicates with subordinate clauses, things like think, know, say, forget, things that we will hear about. So these are really cool, large-scale annotated data sets that allow us to test a variety of theoretical properties of relevant expressions and constructions in both semantics and pragmatics. This has since grown into an entire mega franchise. There now is mega acceptability, mega veridicality, mega neg raising, mega intentionality, and mega orientation, all in the same spirit, looking at a variety of current and important theoretical issues using these really cool and innovative toolkits. In addition to these and various other methodological contributions, for example, on how to model judgment data, stuff we'll hear about today, he's also worked on a variety of computational projects on summarization, information extraction, and event individuation. He publishes widely, both in computer science and linguistics. And today we'll see some of this work on a topic that's very dear to me, characterizing variation in certainty and uncertainty about inferences associated with what's traditionally considered presuppositional expressions. I think we're in for a mega treat. Let's welcome Aaron.
Great, thank you so much for the wonderful introduction, and thank you all for having me. So before I get started, why are we not working? Oops. Before I get started, the QR code will take you to the slides. You can also get them via a link on the presentations page on my website if you would like to look back at them. The appendices go to O, so there's lots of stuff I won't be covering, and you can check it out after the talk. And I'm happy to talk about it after the talk. All right, so one of the big questions that we semanticists are interested in is what kinds of things do we know when we know the meaning of a linguistic expression, right? So one kind of knowledge that we have is how the expression can move the conversation forward when we use it, right? So say we have this sort of shared picture of the world. When I go about asserting something like Leo ran the race, maybe I'm proposing to insert the content of Leo ran the race into our shared picture of the world. When I ask a question like, did Leo run the race? Maybe I'm proposing two alternatives that might be inserted, Leo ran the race and Leo didn't run the race, and then requesting that we figure out which one we should put in our shared picture. Another kind of knowledge is how the conversation has to look to even make sense to use the expression in the first place. Right, so going back to Leo ran the race, to even know what content we would add, it seems like we need to know who Leo is and what we're referring to when we refer to the race. And the same is true when we're talking about the question. Okay, so one surprising fact is that sometimes we don't seem to know whether particular expressions make sense in certain kinds of conversations. So if we take something like Leo won the race, from this, we'll tend to infer that Leo ran in the race, and it seems like it's something about what we know about winning, namely that participation is a precondition of winning, and therefore if Leo won, he must have participated, that we infer that Leo ran in the race, right? But one kind of surprising thing is that this inference goes through even when we sort of question it, right? So we'll often infer, not always, but often infer that from a speaker using something like, did Leo win the race, that they are sort of presupposing that Leo ran in the race. And we'll often refer to this as a projective inference because it projects through what would otherwise cancel entailments, things like questioning or negation, etc. So one, I said it doesn't always go through in cases where we make clear that we shouldn't make the inference go through. So for instance, if I follow up, did Leo win the race with did he even run it? You're no longer going to get this inference, or you're at least going to be uncertain about it, right? And so the question I'm going to be interested in today is, what is this uncertainty about? And I'm going to explore two possibilities. So one is that it's sort of like lexical ambiguity. Maybe it's not specifically lexical ambiguity, but it's sort of like lexical ambiguity. So to give you a sense of what this might look like, consider Leo ran the race again. And again, we inferred from this that Leo ran in the race. And that seems to be undergirded by something we know about ran, namely that one sense it can have is stride quickly, and from this sense we will make the inference. Another sense that you may not have recognized at first is the direct activity sense. Leo is the administrator of the race. He need not have run the race in this particular case. And so even in this context, or even for this particular sentence, there's actually some amount of uncertainty about this inference that was sort of apparently relatively strong. And this uncertainty seems like something that needs to be resolved on particular occasions of use to even determine the speech act's content. Contrast this with our possibility, too, that uncertainty about projective inferences is sort of like vagueness. So take a sentence like Leo ran a marathon in 3 hours and 40 minutes. We might have some uncertainty about whether Leo's marathon was fast. And that uncertainty is going to stick around even if we have relatively vertical representations of the distribution of marathon running times, right? So if the threshold for fast is here, then Leo's marathon wasn't fast. But we don't really know where the threshold is in any particular context. Maybe it can be pushed around by the context. And so this kind of uncertainty generally is going to remain unresolved on particular occasions of use, even though the speech act seems to have sort of a clear content to it, right? So more generally, I'm going to refer to possibility one as the resolved uncertainty possibility, which more generally will involve uncertainty about an expression or context of use that tends to be resolved on particular occasions of use. I'll refer to this second possibility as the unresolved uncertainty possibility, which is the possibility in which the uncertainty is sort of continues to be manifest on all occasions of use. I'm going to furthermore consider a cross-cutting distinction, or two different ways that these two different kinds of uncertainty might be cashed out. So the first way is that we might have resolved or unresolved uncertainty about the conventional meaning of the expression that then percolates up into the discourse. So this will be cases like ambiguity and vagueness. Those will be two instances of resolved and unresolved uncertainty that is conventional in nature. And I'll contrast this with a purely conversational instantiation of resolved or unresolved uncertainty. And what I'll mean by this is uncertainty across possible sort of discrete states of the discourse that is resolved as a matter of integrating an utterance, but need not be uncertainty about the utterance's content itself. So to give you kind of a flavor for what this might mean, we can consider this question, did Leo win the race? And this inference to Leo ran in the race. And so one thing that asking this question might do is to raise a question under discussion, which is sort of a purely discourse level construct. This question under discussion raises two possibilities that, again, we might add to our shared conception of the world, that Leo won the race or that Leo lost the race. And note that in both of these possibilities, Leo ran in the race, and so maybe that's why we infer from did Leo win the race that Leo ran in the race. Contrast this with an alternative question under discussion. Did he even run it? In this case, the alternatives would be something like Leo ran in the race, which would trivially entail that Leo ran in the race, as well as Leo didn't run in the race, which clearly would not. And that's maybe where the uncertainty would come from. It's not really about the meaning of the expression. And we might extend this to talk about purely conversational unresolved uncertainty. Okay, so I take it that if we could get a purely contextual approach to work, we should actually prefer it because we have to say less in principle. So we don't have to pack this information into sort of the conventional meaning of these expressions. And more generally, if we can reduce some kind of knowledge to general communicative principles, I take it that we should. I'm going to argue that's not possible in this case. I'm going to argue, one, that expressions do carry information about preconditions of their use in their conventional meanings. I take it that at least for some kinds of expressions, this isn't controversial. But at least for open class items, I think it becomes more controversial and has been for the items we're going to look at specifically in this talk. And so the second point I want to make is that open class items are at least part of the locus of this information. And I'll say a little bit more about what I mean at least part of as we move through. Okay, so the case study I'm going to take is uncertainty about factive inferences. So these are inferences of the form, does Stacy love that Leo lost the race to Leo lost the race, where the inference is about the truth of the content of the embedded clause underneath this clause embedding predicate. Note that these inferences are a species of projective inference. They are projecting through this questioning operator. The reason I think this is an interesting case study is that the class of predicates that could give rise to factive inferences, namely clause embedding predicates, is large, at least in English. And so we can measure high-level trends across many predicates. And so, one thing that we're going to do shortly is look at, many different predicates, measuring many different predicates' verticality ratings in a variety of contexts. So in the first part, I'm going to ask this question, where does the evidence for uncertainty come from? And so I'll talk a little bit about where we would get plots of the form I just showed you. In the second part, I'm going to ask whether uncertainty about factive inferences is resolved or unresolved, and I'm going to argue there's pretty clear evidence that it's resolved. In the third part, I'm going to ask, are factive inferences semantically encoded or conventionally encoded? And I'm going to argue that I think that there's at least pretty good evidence that they are conventionally encoded. And then I'll talk about the implications for semantic theory. Okay, so where does the evidence for uncertainty in factive inferences come from? It comes from aggregate measures that are derived from inference judgment tasks aimed at capturing projective inferences or verticality inferences more generally. The kind of tasks I'm going to focus on here and are the focus of some of the modeling work that I'll be talking about are from a series of papers by Judith Dagan, Judith Tonhauser, and colleagues. So what this task looks like is there'll be an initial kind of context setting sentence. Elizabeth asked, did Tim pretend that Zoe calculated the tip? Is Elizabeth certain? And then the question is Elizabeth certain that Zoe calculated the tip? And if we get projection, then the certainty should be relatively high. I'm going to focus in particular on a version of this paradigm reported on in this OpenMind paper, where in addition to what I just showed you, there's a context setting fact that will make the embedded clause content either high or low likelihood. So in this case, it's supposed to be high likelihood that Zoe would have calculated the tip, given that she's a math major. And so there are two data sets that we're going to be looking at. One is a norming data set that rates the likelihood of what will be the embedded clause content given the fact. And this will manipulate high and low likelihood content. So in this case, Zoe is 5 years old, unlikely that she calculated the tip. Zoe's a math major, higher likelihood that she calculated the tip. And indeed, you see the kind of distribution of judgments that you would expect. So this is the actual distribution from this particular item from the Dagan and Tonhauser data. The second and crucial data set is this projection data set, where The aim is to measure verticality inferences in the context, kind of in using the paradigm that I just mentioned, and specifically using the facts and contents that were normed. And so in this case, you give this fact to Zoe's a math major, and then you say, Nancy asked, does Tim know that Zoe calculated the tip? And then the question is Nancy certain that Zoe calculated the tip? And in this case, you see that in general, like it tends to be that you give higher likelihood responses. The point of this paper was that you also see modulation on the basis of whether the fact makes the embedded clause content higher or lower likelihood. I'm not going to focus too much on that for current purposes, but it does enter into our modeling. That's kind of a big reason we're using this data set. Okay, and just to contrast the case with pretend, you see that what you might expect from pretend, that you get much more low likelihood responses. And then again, the point in their paper was that there's that the high likelihood contents kind of shift the distribution over slightly to the right. Okay, so how are we gonna use this? So the question I want to look at now is, what are the two hypotheses about uncertainty, resolution or non-resolution, predict about the distribution of judgments? So this is work reported on this recent NLS paper with my former postdoc, Julian Grove, who's now at the University of Florida, and was followed up on in an ELM paper from a couple years ago. Both papers build their models using this framework that Julian and I have been developing called probabilistic dynamic semantics. So I want to talk just a little bit about what's going on here. I'm not going to get into the nitty-gritty details at all. I'm happy to answer questions about them. And you can also see the full implementation on our GitHub. But the basic idea, the basic idea behind this framework is we really want to compositionally derive statistical models of judgment data from kind of a more familiar looking compositional semantics, right? So we want to actually be able to kind of write these little discourses like the ones that you saw in these tasks, including both kind of the actual target sentence and the prompt. We want to then be able to send that through a parser, send the parse through a particular kind of compiler, or you could think of it as a transpiler if you want, and yield a full statistical model of the judgment data. And again, I'm not talking about exactly how this is done here. I'm happy to answer questions about it, but that's what's undergirding these models that I'm about to show you. And the idea behind doing this is that we can define semantic values sort of in the normal way, and distinct hypotheses can be cached out as distinct lexica. Okay, so I want to now consider the two hypotheses. So one is this non-resolution hypothesis, and under this hypothesis, it turns out that the model that you compile out is that judgments should follow a single distribution whose expected value is determined by the predicate and embedded content. So basically, you're going to have some kind of mean response that's going to correspond to the probability that the predicate triggers projection or that the embedded content is true, along with some amount of noise due to non-linguistic factors down to like you just had a jittery hand when you were trying to slide the slider to the exact point that you were targeting. Under the resolution hypothesis, judgments follow a mixture of three distributions, what I'll call the false and true distributions, determined by the predicate, as well as a prior distribution, which is determined by the likelihood of the embedded clause content. And this is where the relevance of the norming data comes in, because that's how we estimate the prior probability of the embedded clause content, given the fact at hand. So to kind of visualize this, you would have kind of three positions, one at 0, one at 1, and then one at, say, the prior, where the height of this will be the probability that the predicate triggers projection. The height of this is the probability that the predicate triggers projection not. And then the rest of the height is allocated to our prior distribution, where the position on the x-axis of this prior distribution is determined by the probability that the embedded content is true. And in this case, we also allow for noise due to non-linguistic factors. And so the full distribution of data will be kind of a sum of all of these particular distributions. Okay, so what I'm now going to talk about is the fits that we observe for both the norming data and the projection data. So the interesting bit is the projection data. Those are the kind of crucial fits. But I want to show you that when we fit these kinds of models to the norming data, we actually observe different behavior than when we fit to the projection data. Okay, so this is going to allow us to answer this first question about whether uncertainty about prior beliefs themselves are resolved or unresolved. Now, this is really yeah. I have no prior beliefs about what this should look like. This kind of doesn't have to do with projection itself. It just has to do with kind of relationships between facts in the world and contents. But it's interesting because it's going to show us that these models don't kind of preference one solution over another. So along the x-axis, I'm going to show the unresolved model and the unresolved and resolved models. Along the y-axis, I'm going to show you a measure of fit called ELPD. And what this measure does, basically you interpret higher means, higher meaning better fit on ELPD. And what this measure does is it basically tells you both how well the model fits to the data, and I'll give you a visualization of what fit means in a second, as well as how complex the model is. So note that the resolved model is actually substantially more complex. ELPD penalizes the resolved model for being more complex because it basically has more possible ways of fitting the data. Okay, so again, higher means better. And so on the norming data, that is just the data that says, Zoe's a math major, how likely is it that she calculated the tip? We see that a model that assumes that uncertainty about that likelihood is unresolved does substantially better. So just to give you a sense for what this looks like, the unresolved model can kind of fit the fact that you have this like one mode here, whereas the resolved model really wants to put the mode at 1. Okay. So again, this is for the norming data. The crucial question is now about the factive inferences. So about the kind of second data set. And so this question is uncertainty about factive inferences resolved or unresolved? So I'm going to show you along the x-axis here are 4 different models. The 2 to the left are kind of the ones that I visualized for you schematically at the beginning. I'll say a little bit more about what the 2 to the right are in a second. We're going to then plot ELPD. And what we observe here is that the model that assumes that factivity is resolved substantially outperforms the one that assumes that factivity is unresolved. And I will show you the fits to give you a sense for why this happens. These other 2 models are instances of a factivity unresolved and factivity resolved model, but ones that actually treat the embedded clause content as though it were resolved. So these ones assume that the uncertainty follows the kind of pattern that we observed with the norming data, namely that embedded clause content has sort of unresolved uncertainty about it. These ones are suppose that we assumed that the embedded, that the content, for whatever reason, when we're judging kind of these factive inferences, people really want that content to be resolved for whatever reason. And it turns out that the factivity unresolved model does slightly better in this circumstance, but not nearly as well as the model that assumes that that factivity is resolved, and actually the other factivity resolved model does substantially better than that one. Okay, so we conclude from this that uncertainty about factive inferences is resolved uncertainty. So why do we get this pattern? Well, let's actually look at the distribution of responses and what fits we actually observe. So basically, what happens is that the unresolved model just simply doesn't have kind of enough flexibility to actually fit the data because it's unimodal. So it gives you kind of this smoother output than either of the resolved models, which actually are able to kind of fit the data better. Okay. Few questions you might have here. One is maybe it's just this prompt that is encouraging participants to respond more discreetly because it's a polar question. We actually looked at this question in the context of this Elm proceedings paper by manipulating a variety of different prompts that aren't polar questions. I'm not going to kind of go over that here, but the basic idea is that we can collect new data under different prompts, and the only thing we need to change about how we do the modeling is slotting in a new question and for Q1 here. And then we compile out different models based on our assumptions about the semantics of the question. So we're actually explicitly modeling the semantics of the prompts in addition to the semantics of the target sentences. Another question you might have is, does having kind of biased contents, ones that are biased high or low, cause people to respond more discreetly? And the answer to this is also no. I can talk a little bit more about this after, but basically what we did is manipulated the nature of the contents so that they could not, in fact, have high or low likelihoods. And we report on this in the NLS paper. Okay, so question we started with in this section is uncertainty about factivity inferences resolved or unresolved. It's resolved, which suggests that we're somewhere in this row. Okay. So the next question I want to ask is this resolved uncertainty about the sort of some conventionalized meaning of these predicates, or is it about is it purely contextual in nature? And the predictions are that if there were such a semantically encoded property that's sort of driving these factive inferences, it should show a trace both in the inference judgment profiles, which we've already been seeing, but also it should show a trace. Show a trace sort of in the actual syntactic distribution of these predicates as well. Otherwise, there's not really any reason to believe that it's sort of actually semantic in nature rather than purely pragmatic. Okay. And so going back to this plot, which is actually showing a measurement across a bunch of different predicates that came from a data set that Kyle Rollins and I built a while back, what you see is that there's sort of, it's not really super clear that you should believe that there's actually any kind of pattern in this data. Like these predicates don't really appear to cluster. So it's kind of hard to understand how it could be the case that there's actually that there's sort of classes of factive predicates that could then sort of correlate with syntactic distribution. So I want to consider two possibilities for why we see this sort of gradients and this kind of apparent lack of clustering. So the first possibility is that the lack of apparent clustering may be due to some noise in the measurement, which is something that we were sort of modeling in our inference judgment tasks at a smaller scale. And what we want to do is kind of scale that up to understand this possibility. To give you a sense for what this might look like, what I'm going to do is plot for you on the x-axis and y-axis judgments from this data set that Kyle and I built. And basically what these judgments were judgments to are items of the form, someone blanked that a particular thing happened. Did that thing happen? Yes or no. There's also a maybe option. And on the y-axis, I'm going to give you that, but with negation in the matrix. So someone didn't blank that a particular thing happened. Did that thing happen? So every point in this plot is going to be a predicate. There's about 500 or so of them. Sorry, this is yes and no. And so what you should expect is that things that are kind of traditionally factive should show up here. You should be answering yes regardless of the negation. Things that are what are often termed vertical should show up here. So if they give rise to the inference in the positive but not the negative matrix polarity, then it's plausibly that this is an entailment rather than a presupposition. Non-factive should show up here, and anti-vertical should show up here. So this is what the distribution ends up looking like. So you see things that are traditionally factive kind of generally are higher up there, like hate, forget, love, realize, be surprised, etc. Things that are traditionally classed as vertical, like show and prove, show up kind of where you would expect. Things that are traditionally non-factive, non-vertical, like believe, hope, think, suppose, etc., show up in the middle. And then you have things like pretend in the anti-vertical area. Okay, so one thing to notice here is that this looks like a big smear if you look at it this way. But if you actually look at a density plot, it's quite clear that there's dense areas. And there's dense areas sort of exactly where you should expect the dense areas to be. And so the second possibility I want to consider is that, well, so I think this one possibility is that this is just noise in the measurement. The second possibility I want to consider on the basis of kind of observing these sort of dense areas is that this lack of apparent clustering may be due to predicates that are sort of polysemous with respect to factive and non-factive subclasses of clause-embedding predicates. So to give you a sense for what this might mean, consider that it worries Leo that Thea left is going to give rise to this inference that Thea left. And this will happen in the negative matrix polarity as well. But if I just change the syntactic structure very slightly, but kind of keep the same content, I no longer get this inference. Okay. So the question I want to ask in the next section of the talk is, if we develop a model that accounts for measurement noise and the possibility of polysemy, are factive inferences actually correlated with distribution, and do we see kind of clear clusters? Okay, so the way that we're going to go about doing this is to attempt to induce a full classification of the clause embedding lexicon from both inference judgment data and a measurement of distribution. Okay, so what do I mean by a classification? Well, consider kind of traditional classifications of clause embedding predicates. So I'm going to talk about three kind of traditional classes that you might expect to see. So one is the cognitive non-factives, like think or suspect. These will tend to give rise without any entailment canceling operators to inferences about belief. The cognitive semi-factives, which like know and realize, which tend to give rise to inferences about belief, but also which tend to give rise to verticality inferences. And the positive emotive factives, like and be happy, which give rise to these inferences as well as some kind of desire inference. When we put any of these in the matrix, when we combine any of these with negative matrix polarity, that allows us to kind of see projective behavior. So traditionally, cognitive non-factives, we tend to assume that their belief inferences are likely entailments, because when we put them in the negative matrix polarity, we no longer get the belief inference. The cognitive semi-factives, we tend to also believe that the belief inferences are entailments because, again, when we put them in the negative matrix polarity, the entailment doesn't go through, but the verticality inference classically is assumed to project. And with the positive emotive factives, we still get both of these inferences, but no longer get the desire inference, which we tend to take to be an entailment, right? So when I talk about a classification, what I'm talking about are classifications like this sort of classical one where we define them both in terms of inference judgment patterns and then ask how are they related to the syntactic distribution of these predicates. Okay. The reason why we're interested in syntactic distribution is that we want to really make sure that the induced classes are in some sense cohesive with respect to both inference and distribution, and thus at least plausibly semantic. Okay? So this is work that my students Ben and Will did a while back. So this is a SALT paper, and we have another paper that's in prep, which is what I'm actually going to be reporting on. Okay, and so the question I'm going to be interested in is, are any of the induced classes that we see when we kind of take this big, these like multiple like distribution measurement and inference measurement data sets and try to kind of cluster on top of them, are any of them associated with factive inferences, whether or not those classes are sort of consistent with the prior literature or not? Okay, so there's a few data components. So one is, how do we go about actually measuring distribution? And so we'll do this using kind of a standard acceptability judgment data set. And then how do we go about measuring inferences beyond factive inferences? Okay. So measuring distribution, this is work reported on in a couple papers with Kyle Rollins. This is the mega acceptability data set that Florian mentioned. So this data set has acceptability for 1,000 verbs and 50 different syntactic frames, which are generally focused on clause embedding. So these are kind of all the verbs that you might want. These things like think, know, wonder, love, surprise, tell, say, start, stop, etc. And the way that we measure acceptability is by taking these kind of templatic syntactic frames and instantiating them with semantically bleached fillers. So these will be frames of the form someone blanked something happens, so kind of NP blank CP. Someone blanked that something happened, so we're manipulating things like the presence or absence of complementizers. Someone blanked whether something happened, which thing happened, so manipulating the nature of an embedded interrogative. Someone blanked someone that something happened, so manipulating whether the predicate is transitive or not. We also have a variety of manipulations of the finiteness of the embedded clause as well. I'm not going to be focusing too much on non-finiteness here. I'm going to focus mainly on the finite complements, since that's where a lot of the literature is focused. So this gives us 50,000 total items, and we have 5 judgments per item. One question you might have is, is bleaching a valid way of capturing the acceptability of a verb in a frame? We've taken a few different approaches to validating this strategy. So one is to compare judgments for bleached items against judgments for trained linguists. I can talk about that if people are interested. I have an appendix on it. Another is to assess generalizations drawn from linguist hand coding of acceptability across many predicates against the data. So I can talk about that in Appendix E if people are interested. Okay, so for the inference judgment data, we're going to kind of take the same recipe where what we did for many of the data sets I'm going to be talking about, I'm going to focus mainly on the verticality one, is we validated a bleaching paradigm for collecting judgments for particular inference types. I'll say what I mean by inference types in a second. We then selected a set of frames of interest. So, are we interested in the finite complements? Are we interested also in the infinitival complements? What kinds of other non-finite complements are we interested in? Selected predicates acceptable in those frames using mega acceptability, and then collected judgments using the paradigm. So I'll give you just a sense of the verticality task. I have kind of appendix slides on the other tasks if people are interested, but basically what the verticality task, which I've already kind of shown you data from, looks like is, again, someone was irritated that a particular thing happened. So it would be someone blanked that a particular thing happened. In this case, was irritated. Did that thing happen? Presumably you answer yes, or people did answer yes in most cases there. And again, we manipulated the syntactic structure that these were found in. So we have finite complements. We manipulated the voice. I can say a little more about that later if people are interested, as well as a bunch of non-finite complements, mainly infinitivals in this case. Again, I'm going to be focusing mostly on these for current purposes. So you might wonder, well, how well do these judgments actually correlate with the data sets that I was showing you before with more contentful judgments? The answer is they correlate at a very high level, so something like 0.7, which the experimentalists will know is not a correlation you kind of tend to see in experimental tasks. We also have a few other tasks and data that we're kind of piling into this model. I'm not going to focus too much on the tasks themselves, but again, I'm happy to talk about them. I have appendix slides on them. So we have a belief task that assesses the inference from NP blank S to NP believe S, a desire task, an intention task, and a neg raising task. Again, I'm happy to talk about these after if people are interested. Okay. So again, you might wonder if a bleaching method is okay for capturing inferences associated with a verb in a frame. We've taken a few different validation strategies. I have some appendix slides on them. One is to compare judgments for bleached items against judgments from trained linguists. Another is to compare judgments for bleached items to judgments for more contentful items. You already saw an instance of that. The third is to compare inference judgments for bleach items to acceptability judgments for known distributional diagnostics that are supposed to actually correlate with those inference judgments. Again, I can talk about any of these after if people are interested. Okay, so how do we actually go about discovering these patterns? The idea is going to be to cluster predicate frame pairs in what I'll call inference space using a multi-view mixed effects mixture model. So I'm going to explain what all parts of that mean. So basically what we're trying to do is find these dense areas. And we're trying to do that across all the different judgment types, including the acceptability judgment types. Right? So if we have a predicate like no, the model is going to assume that there are some kind of latent or unseen inference/distribution patterns, and that these distribution patterns, each such pattern is associated, or cluster, is associated with a distribution over acceptability and various kinds of inference judgments in each of these particular kinds of tasks. The mixed effects part of this is that participants can kind of modulate these average distributions in the same way that if you've ever run a mixed effects model on your experimental data, your kind of subject random intercepts are modulating the distribution. Okay, and we're going to do this for all frames simultaneously. So we're just piling all of this into a single model. Okay. We'll then fit this to all the data sets that I just talked about using a particular kind of estimation procedure called map estimation. And the output is going to be a distribution over inference plus distribution patterns for each verb. So that will correspond to this, as well as for each inference pattern distributions over the judgments for each frame and inference type. So that will be these things. And so one question we have to answer before we even look at this is how many inference patterns should we actually go about assuming? So I just said, we assume there's some latent number of inference patterns. The idea is going to be that we want only as many as we need to predict the judgments for verb frame judgment type tuples we have not observed when fitting the model. So what we do is we select the smallest clustering for which no larger clustering improves prediction of held out tuples. So we hold out some amount of the data. We don't let the model see it. We fit to it. And then we ask, how well were you able to predict that held out data? And so then what I'm going to show you here is if we sweep that number of inference plus distribution patterns from 1 up to actually even higher than this, up to, I think, 50, how much do we, how well can we explain the actual held out data? And so what you see here is that you start to kind of saturate, in the 10-ish region. But actually, by the time you get to about 25 is when you stop improving on any kind of finer grained clustering. So what I'm going to do is then look at these 25. One thing I want to say about these 25 is there's not really, I don't think there's anything special about this number. It's really partly about the data that we were looking at. So I think the interpretation here is really that there are at least 25 distributionally correlated inference patterns. The other thing to note is that not all inference distribution patterns instantiated by a particular predicate are going to get their own inference pattern, because crucially, we want only ones that are sort of correlated with syntactic distribution, and presumably not all possible inference patterns instantiated by a predicate are actually correlated with syntactic distribution. The second important point is that, and this is related to what I was just saying, is that enriching that distributional representation or range of inferences could kind of increase the granularity of patterns. So, so again, there's not really anything special about 25 here. Okay, so the question I now want to ask relatively quickly is, do we observe subclasses that consistently give rise to factive inferences? And the idea here is that if we observe such subclasses, which again, by the very construction of the model, are constrained to explain distribution, that's consistent with factivity being semantically represented. Okay, so what I'm going to be showing you here are these distributions, and I'm specifically going to be showing you the means of these distributions, because that's the easiest way to actually show them. And I'm going to be giving names to these. These are names that I, as an analyst, have been giving based on manual analysis. Okay, so I'm not going to talk about all of these. I'm going to just pick through three of them, the three that I've already discussed. So, but if you're interested, and I can go back through kind of how we get this particular clustering of clusters. Yeah, so I'll walk through a few of these classes. So the first is the cognitive semifactive. So it turns out that we find a class that corresponds extremely closely to what we would have expected as semanticists coming at this without any fancy methods, including things like discover, realize, recognize, know, find out, and understand. So what we see, if we go look at the actual distributions associated with this particular class, or each of these particular classes, what I'm going to do is I'm going to plot the classes along the x-axis. I'm going to plot frames along the y-axis, and so and then I'm going to, in each of these cells, I'm going to plot the kind of mean likelihood associated with the relevant inference for these frames. So orange is high and blue is low. And so for factivity, for projection, we're looking for 2 oranges. So it turns out that for the cognitive semifactives, we see that they are associated with giving rise to the verticality inference in both the positive polarity and in the negative polarity. This is kind of the signature that we would expect for factivity. I'm not going to talk too much about the rest of these frames, but there's actually quite a bit of interesting stuff going on across other syntactic frames. Note further that some of these are going to be empty for cases where the actual class doesn't occur in the particular frame. OK, so I'm running a bit low on time, so I'm going to skip the discussion of kind of the syntactic stuff for now. But I want to just show you that we also find non-factive variants. So this can be seen if we look at the representationals. So if you look across this particular row here, you'll notice that we don't give rise to the verticality inference in either the positive or the negative for things like dream, hope, think, and assume. And again, these are not good in certain kinds of frames. I'm going to skip the stuff about belief inferences. And I'll just show you real quick that we see what we would expect for positive internal emotives, which turn out to be factive as well, which, remember, is indicated by seeing sort of 2 oranges here. OK, so this means that we have a class that involves something like someone was or wasn't pleased that a particular thing happened. From that, we infer that that thing happened. OK. I'm going to walk through these. So I just want to get to the upshot. So the upshot is that we do observe classes that recapitulate part of the standard classification of clause embedding predicates. And remember that this was all kind of targeted at answering this question of, if we develop a model that accounts for measurement noise and the possibility of multiple subclasses, do we see that factive inferences are correlated with distribution? The answer is yes. And actually, you find exactly the classes that you would have expected, even though you saw this kind of like muddy looking, very gradient looking junk in the data originally. So I think the upshot here is that this correlation is at least consistent with the drivers of factive inferences being semantically represented. And therefore, I really think we're somewhere in something like this cell. Okay. So I want to make two important points here before concluding. So the first is that the relationship between the semantic drivers and the factive inferences may be indirect, right? So it may be the case that we derive certain inferences, say the factive inferences, on the basis of other content that is still kind of a lexically encoded precondition of use. So for instance, via, say, a default credence inference. The second important point is that the information the predicate provides may be sort of purely formal in nature. So it may be that predicates kind of select morphemes that themselves drive factive inferences. And I think there's quite a bit of evidence cross-linguistically that this happens at least in some languages. Okay. The third is that purely a contextual account could still be possible, but it really needs to explain why we see distributional correlations in the first place. If there's no kind of a semantic driver. And then finally, it's not like we've obviated the need for a pragmatic story, because we still need to say how we determine which linguistic expression is actually getting used if we go for a resolved conventional account, as I'm arguing for. Okay. Right, so just to conclude, I started with this very big question we semanticists are interested in. What kinds of things do we know when we know the meaning of a linguistic expression? We talked about two kinds of knowledge. One is how the expression moves the conversation forward. Another is what needs to be the case for it to be used in the first place. And we focused on that. In this talk, I argued that expressions do in fact carry information about preconditions of use in their semantics, and specifically, open class items are at least part of the locus of that information. So one question you might still have is, why would we see predicates semantically, or at least distributionally, encoding their preconditions of use? And I think one possible answer to this is that it might be very hard to learn these preconditions otherwise. And I think there's pretty good evidence for this by some work from Rachel Dudley's dissertation on learning learning factivity, where she finds that simply tracking the discourse status of the embedded clause content in child-directed speech and trying to kind of correlate it with which predicate is being used is very unlikely to work, because those correlations are actually quite weak. Thanks.
Questions? I think you can field your own.
Yeah, so I think they're piped through Zoom or something, I think you'd said, or? Okay. I'll
start out if you want to go.
Okay.
So picking up a little bit on stuff that went over a little fast, super cool. It's great to also see that some parts of it before, but right. So it seems like there's more fleshing out to be done, more to be said. Time for. On the one hand, there's a story that for conventionalization, which typically is going to go towards putting this information in the lexicon associated with individual verb or predicate. And then we have this interesting dimension that went by kind of quickly, quite a bit of variation based on the syntactic frames, which clearly suggests that, well, if there is conventionalization in the lexicon, that has to interact somehow with the syntax. And just sort of big picture level, I would ask you what direction you're in.
Yeah, so I actually want to make it clear that I am not claiming that it's necessarily a fact about the predicate semantics. This is why I'm careful to say it's at least part of the locus, because it could very well be the case that it's knowledge that you have about how frequently the predicate occurs with functional architecture that's relevant. So for instance, if you I think the evidence for this is clear in non-English languages, but like if you believe that English has distinct factive and non-factive complementizers that have some kind of definiteness-like property to them, then it might be the case that what is that this predicate kind of occurs with that marker with some frequency. But the predicate still, of course, needs to be compatible with that marker. Like it can't be that like semantically you get a contradiction or something by combining the predicate with that marker. With respect to variability across frames, so for at least certain cases, I think. So for at least certain cases, I think that I'm trying to think of how to exactly word this. There are probably the factivity doesn't go away. So this is something I looked at a while ago with predicates like remember and forget, where remember and forget, even when so these are kind of classically cases where it looks initially like the inference pattern is being modulated by the syntactic structure. So if you say John remembered that Mary left, John didn't remember that Mary left, you get the factive inference. John remembered to take out the trash, John didn't remember to take out the trash. You definitely don't get the inference that John took out the trash in the second case. So these are cases that flip from factive to what's often called implicative. And forget is kind of the inverse. So in that case, it's not really that I have argued that it's not really that the factivity goes away, because you actually do get a presupposition in the remember to case about an obligation. So you get this or it's probably actually more general than this. It's some kind of root modality. So if you remember to do something or don't remember to do something, in both cases, there is a projective inference about your plan or obligation or something like that to actually do it. And then my suspicion is that there's some interaction in that particular case between the root modality and aspect. So I think my answer is that it's probably like on a case-by-case basis, there are explanations of this form for a lot of these kinds of predicates, especially when you start talking about non-finite complements where like restructuring is happening, or like depending on the language, things like restructuring might be happening, kind of wonky stuff might be happening with aspect. Not all non-finite complements probably have the same like underlying structure. So I think there's just a lot more to be explored on trying to explain where this kind of variation, occurs.
Maybe on a very broad level. So you're talking about what does that mean? I mean, already talked a little bit about that, but is it a binary thing, like that's coded, or is there something that allows for the variation data from? The other question I had that's maybe related to that is the groupings that you observe among the predicates. Do those correspond? You did show a little bit of that, but it's not obvious what this do. And do those correspond to maybe 5 different cases?
Yeah, so first, I have not said anything about how factivity would be encoded. And as I was saying in my response to Florian, it may not really even be a fact about the predicate alone. Like it may well be encoded by saying it's sort of factive compatible, which I think is kind of like what it looks like in the case of like a language like Turkish. So I don't have a position on whether there's a binary distinction or not. I do have a position on whether what you on particular occasions of use, whether the inference itself is gradient or not, and it is certainly not. It's just, I think, clearly the case that it's not. And then, there is a question like, how do you get that particular kind of variability? And I think there may be different answers for different classes of predicates, which I think is relevant for your second. So for instance, like in the case of the emotive factives, I would be totally happy with a default credence inference kind of generating that factive inference, where I don't see how you would do the same thing with, say, like a cognitive semifactive. Yeah. Yeah.
What is the result
That on particular instances of use, it's not gradient. Is that the question?
it's not a gradient?
I mean, largely because people don't treat it like a gradient. I mean, they're like, if you go back and look at these, so I think that this is, I was talking with Charles about this. This is kind of this is very closely related to debates that we've had for a long time in the context of interpreting learning curves, where, there's all this classic literature on trying to understand why we see smooth learning curves. And then if you actually go look at the data, it's like you learn it on a trial or you don't. And then if you aggregate, of course, you're going to see learning curves across the population. I think that's exactly what's happening here. Like this is really just a mirage of aggregation. So like, it's quite clear that people are kind of doing endpoint responding in this particular case, for instance, in a way that they don't do that kind of endpoint responding when you're just asking them to judge the likelihood of something.
I'll ask one more question.
Yeah.
Also very sort of general and maybe speaks to other people. As well, you sort of referenced the other prior work suggesting that the discourse status of the embedded content alone is not a good way of learning activity.
Mm-hmm.
So that's sort of a negative take of like, well, that it couldn't be like that because you couldn't learn it. Do you have any thoughts on sort of a positive thinking about how is the sort of structuring of the information and where it's located in terms of what you propose? How is that learnable? Because that seems also like a tall order. Right?
I mean, I think the answer is similar to any kind of syntactic bootstrapping account, right? Like you need to have some amount of knowledge about the relationship between concepts and like at least very abstract distributional categories of some kind or other. And cashing that out is non-trivial, of course. Yeah, but I am convinced by the Dudley et al. Work that you do need to have something that's at least a partially a syntactic bootstrapping based account for doing that, for that learning story.
Last chance for questions.
So I'm interested in this question of gradient. Did talk about world knowledge.
Hmm. Yeah.
So I know you don't have it.
Well, I think that is sort of the point of the low-high manipulation of the original Dagen and Tonhauser studies, is to try to modulate. I might be not understanding your question, but their studies were attempting to kind of like push around the judgments by pushing around how likely the content was on like on the basis of some given fact. And now it's maybe not quite as extreme as that particular case, but you do see that modulation, but it doesn't kind of force, for instance, the responding behavior to become unimodal when you have kind of like extreme high or low likelihood responses. But I might not be understanding your question, so uh, can you guide me to help understand your question better?
I guess maybe it's more general, but we're
So within the framework that we are working, they fit into priors on the common ground, or yeah, in that case, it would be priors on the common ground. So we distinguish. Oh, can you give the example again? Sorry. Yeah, sure. I think that's fine. In this particular framework, we can index common grounds, or we can index by speakers. Yeah. Yeah. We just don't have data. Yeah. So actually, in this, not everything's bleached in this section. This is using these actual kind of contentful cases, but in principle, the like speaker identity can be injected into those priors on common grounds. Yeah, if again, I might not be understanding your question. I'm sorry. Yeah. Okay. Yeah. Thanks.
All right, I think with that, we'll call it a wrap. Thank you so much, Aaron. Let's make this super.
Yeah. Thank you.